Okay, this is the operation and maintenance exam review for the operator certification test. When you take the test, you're going to need to know what some of the acronyms are. Your gallons per minute is GPM, million gallons per day is MGD, THMs is total trihalomethanes. When you're talking about parts per million, milligrams per liter, or parts per million are the same. And TON is a threshold odor number for odor in water, and it should be conducted at 60 degrees. Also remember that text that is in red and highlighted is text that you may see on the test or you will need to know to take the test. When you're monitoring your system to ensure the water is safe, you're going to monitor it for bacteria, turbidity, and the chlorine residual. When you take your samples, they should be filled just above the fill line, or about 1 inch from the top. That is a test question. The bottles need to be sterilized by the lab and ready to use when you take them out into the field. The bottles have a powder in them that's sodium thiosulfate, and that powder is used to neutralize any chlorine in the water. Your sampling procedures, you should allow the tap water to run for several minutes or as long as it's necessary to clear the service line. Generally, when you get a glass of water in the morning, you put your finger under the water and you'll wait till the water gets cold to take a glass of water because colder water is better, but that's generally an indication that the water is coming from the distribution main. You need to know that the results are meaningless if you contaminate the sample, so you don't want to even take the cap off your sample bottle until you're ready to take it, and you don't set the cap down on the ground or touch the inside of it. You want to keep that sample as sterile as possible as far as keeping your fingers and keeping any contamination out of that the cap or the bottle itself. Make sure you the identification cards are filled out completely. And if you have red water, it could indicate bacteria, and also could indicate an electrochemical phenomenon going on in the water. If you take a sample and the sample was okay, that only means it was safe at the point that you took the sample. They will test that sample for coliform, and that's an indicator of the presence of bacteria in the water, and if the absence of coliform in the water indicates the water is safe. The sample should be transported as soon as possible in a cool container with ice pack, and the routine samples should be taken at the customer's tap at various points that represent the entire system. Make sure you also fill out your chain of custody forms, that they're filled out completely. I've got this sample tap over here, and that's not a good place to take a sample. If you'll notice, it's got a hose bib vacuum breaker on it, and there's threads, and those can harbor bacteria on the inside and will mess up your sample. Composite samples are a series of grab samples taken at the same sampling point and at different times, and they're mixed together. They represent instantaneous conditions at the time and location that the sample was taken. Nitrates, we monitor for nitrates. Fertilizing lawns and farms can cause elevated levels of nitrates. They can also cause something known as blue baby syndrome, where the nitrates, if it gets into your system, can rob your blood of oxygen, and babies are susceptible to suffocation from nitrates in the water. NTUs, nephelometric turbidity units, that's the method that's used to measure the cloudiness of the water. The higher the NTU, the dirtier the water, and the greater possibility of microbial contamination. Turbidity can mask the bacteria. The bacteria in the water can hide behind the turbidity in the water, so the chlorine or UV can't come in contact with it. I compare this to in the middle of the summer when it's hot outside, you're trying to find shade to escape the sunlight. And that's the same with bacteria. It tries to get in the shade to get away from it. The use of light, they use a light infraction to measure the turbidity in the water. Particle counters, it's a method used to measure the cloudiness of the water and the amount of particles and the size of the particles. The dirtier the water, the greater the possibility of microbiological contamination. Weirs, this is a test question that a lot of people have problems with. It's measured from the crest of the weir to the horizontal water surface in the weir stilling basin. The membrane filter test, that analyzes coliform bacteria colonies. Any positive sample requires repeats, and more than one positive sample is a quality violation. The groundwater rule went into effect December 1st of 2009, and if you have coliform positive bacteria samples, it requires a triggered source water sample. All of the sources that were in operation at the time of the coliform positive sample, and you can email us on the sources that not sampled that were not running at the time. Then you test for fecal coliform. If the first triggered source water sample is fecal positive, you need to take 5 additional samples. 2 or more sources requires you submit a new sample site plan, and you have to correct the deficiency within 120 days. The new minimum PSI standards as of March 1st of 2007 are 20 pounds per square inch during a fire flow. You have to maintain the 20 PSI. During peak instantaneous demand, it's 30 PSI, and peak daily demand is 40 PSI. The pressures of water is measured in pounds per square inch, or PSI. Sanitary surveys, they're performed every 3 years. Division of Drinking Water personnel, district engineers, local health departments, Forest Service engineers, the rural water staff or consulting engineers, or anybody that's authorized by the executive secretary or director of drinking water can perform a sanitary survey. Aesthetics means that the water is attractive or appealing. When you're talking about with respect to water, it has to do with taste, odor, and the color of the water. Things that affect this are hardness and total dissolved solids, or TDS. And the effects of that range from a bad smell or poor taste. They can cause stains on your laundry and your fixtures. If you smell rotten eggs, that's generally hydrogen sulfide that's causing that in the water. Water storage reservoirs provide adequate water during peak demands. They provide the adequate pressures throughout the water system. They need to be covered. It's ruled that they're covered to prevent algae and bacterial growth. They're also reserve storage, and they also provide adequate pressure and volume for fighting fires. These storage reservoirs are most susceptible to degradation from the external sources. The volume of the tank, or the amount of water, is measured as volume. Screen sizes, number 14 mesh for air vents. That's 14 squares per linear inch. Air vacs, vent pipe should be above the flood line. So it needs to be a gooseneck. It needs to be downturned and above areas where it's possible to flood. They use a number 4 mesh screen, or 4 squares per linear inch, for overflow lines that water can come through. And so those are your screen sizes. Pressure tanks are your hydropneumatic tanks. They should be able to discharge at the pumping rate on your blow-offs. If you have frequent on and off cycling of the booster pump, that shows a lack of air in the tank, and that means that it's waterlogged. That is a test question. Water or reservoir maintenance, you should do a comprehensive inspection when you clean the inside of the tank, and they should be done every 3 to 5 years or more frequently if possible. You want to make any repairs, you want to inspect the inside of the tank, you want to disinfect it when you're done. Take your back T samples to ensure that you've got good water in that tank. You want to also, in the wintertime, you want to inspect your air vents on those tanks for ice. They can ice over, and if you have a sudden draw in the tank, you can collapse it, as in this picture you see on the right. For coatings on the inside of the tank, there's long and short life. There's a test question on the types of coatings, and so the answers, there's long and short life coatings. Surface water reservoirs, the main reason is for turnover. The main reason for turnover is a change in the surface water temperature and density. They act as a pre-sedimentation basin, so that a lot of the particulate matter settles out into the surface water reservoir. The SCBA, the self-contained breathing apparatus, you should always use that when you have gas leaks and in oxygen deficient areas. You should always have an SCBA on. If you use a canister mask when you're in a room and you get a chlorine leak or a gas leak, you want to exit the room and put on an SCBA. Don't stay in the room with the canister type mask. Confined spaces, reservoir entry sites are confined spaces. Places where chemicals are stored are confined spaces. Another thing you want to be careful of is you want to make sure that if you're parked around a manhole, you want to turn your vehicle off, because the carbon monoxide can work its way down into the tank. The minimum oxygen level is 19.5%. Remember that for the exam, because that you may see that. All chemicals should be stored according to the manufacturer specs. So make sure that, again, anything on the test, any multiple choice answer that tells you to follow the manufacturer specs is where you want to, that'll be the correct answer. A chemical compound has multiple chemicals, such as calcium carbonate. Tank maintenance, on your cycling of the water, you use that to prevent the filling and emptying of the tank, helps prevent freezing. Cathodic protection is used for corrosion where the sacrificial anode is placed in the water, and so that helps protect the tank walls. The age of the water in the tank are attributed to quality problems, and that is caused by low demand or short circuiting. If you have to go in and do repairs on the tank to paint them, they recommend sandblasting for preparing the interior of the tank. It should be sampled for possible water quality changes periodically. When you disinfect a tank, it should be disinfected after you've cleaned it and repaired and painted. It should be disinfected as per American Water Works Association Standards C652. A full tank, you can disinfect it, a full reservoir at 10 parts per million for 24 hours, or 6 hours to 24 hours. Spraying the interior of the tank, you can do that with 200 parts per million, and you need to let it sit for 30 minutes. You can fill it 5% at 50 parts per million for 6 hours, and then fill the rest of the tank with less than 2 parts per million for 24 hours. At least one back T sample should be, you should take at least one back T sample. When you have a distribution system, the leaks generally get worse. That's on the test. When you do a water audit, what you're trying to identify is water and revenue losses. Leak surveys should be done during low flows. If you have a cracked main, it should be replaced. Pressures can be measured at a fire hydrant or a pressure regulating station. And your distribution system pressures should be 20 PSI at all times, and the minimum water main size is 8 inches with fire hydrants, unless you have an engineer that will buy off on it, and then 4 inches without fire hydrants. Water mains need to be 10 feet of horizontal distance from the sewer main. If you cross a water and a sewer main, there needs to be at least 18 inches of separation between the two, and the water line needs to be on top. Water and sewer cannot be installed in the same trench. If you get anaerobic growth, that develops it develops in water devoid of oxygen, and that causes odor problems. The hydraulic adequacy is determined by the pressure measurements throughout the system at various times. If you loop a system, you loop it to prevent dead ends and having water quality problems, and also better flows. A Cork Stop is a customer service line, and it's used to shut off the service to a home or one of your residents or businesses. 3/4 is the most common customer service connection. You can thaw a service line with hot water or warm air. You don't want to use a welder because you can create a fire in somebody's electrical panels. And you should also consider a flow rate and pressure for sizing. Whenever you're sizing that service connection, flow rate and pressure are a consideration. Jacking and boring is the most common technique for the construction of a pipeline. If you have to, if that has to go under a freeway or heavily traveled road, they call it jacking and boring, and what they do is they push the line underneath there without having to dig up the road. On your new water mains, there's certain steps that you need to take, and you should pressure and leak test the new main. You want to flush out any debris that's in the line. You want to keep that pipe clean. Then you disinfect that pipe with a PSI Standard C651. You want to take a chlorine residual. You want to flush the highly chlorinated water out. Make sure that you don't flush it out into a storm drain that leads to a river, because you will have fish kill. Your back T samples should be taken at least 24 hours apart under special conditions, and you want to keep the ends of the pipe plugged when they're unmanned so animals and varmints can't get inside the pipeline and get trapped in there. Pressure testing the water main, it should be done at 50% higher than the normal operating pressure, or 150 PSI, whichever is larger. You want to test it for 4 hours, and the new connections that you install on that are called hot taps when they're done under pressure. You never want to shut the main line down completely, because you can create a back siphonage in the line and suck contamination into it. You want to disinfect with tablets or granular at 25 parts per million for 24 hours. Continuous feed, you can do that at 10 parts per million after 24 hours. Fill the main with water, flush out any debris, and fill with chlorinated water. Backfilling the mains, notify other utilities or blue stakes before you dig. The soil should be placed equally on both sides of the pipe halfway up, and you should hand tamp the soil. The pipe should be covered with about 12 inches of soil. When you're talking about well point, that's what they call it's used to dewater the trenches. And you need to know that shallow mains are more susceptible to freezing. That's why they try to bury them below the frost line. Thrust blocking is a concrete mass. You can see that right here on the T, and they place that to keep the fitting from moving and coming apart. You can also use thrust anchors when thrust blocks can't be used. You can use a restrained fitting or use of clamps. And you can also use tie rods used on a mechanical joint fitting. The block should be centered to keep where the force is going to be, to keep it from allowing the fitting to move. They should be placed. The thrust block should be placed behind the foot of the hydrant at the flow line. Fire hydrants. The hydrant bury is the distance below the ground to the main connection. Because of the increased population, growth, and scaling of pipes, hydrant flow tests should be performed periodically after major changes in the distribution system. You can also take a cap off and drop a weighted string down to make sure that your valve isn't leaking inside the hydrant. Hydrants are usually 2.5 to 4.5 inches, and they paint them different colors to show the flow. The hydrant cat color, light blue, is 1,500 gallons per minute or more. The green is 1,000 to 1,500 to 1,499, and the orange is 500 to 999 gallons a minute. And red is less than 500 gallons per minute. When you flush the hydrants, you can stir silt up in the line, and that causes water quality problems. They should be tested for flow with a pitot gauge to make sure that you have an adequate flow so if you have to fight a fire, there's an adequate flow for the firefighters. And they should be metered by contractors. If you have a contractor that hooks onto a meter to fill a tanker or anything like that, you should require them to put a meter on it so you can account for any water loss or water use. On a dry barrel hydrant, the hole drains the barrel. There's a hole in the bottom, a drain hole, and that drains the hydrant barrel down so it doesn't freeze. A partially open drain, water can leak through that drain hole that you can see right down here. You can, if this is partially open, water can leak past that, and so you want to make sure you get a tight shutoff on the valve when it's open. You test those for leakage with the main valve open and the caps on. You can use a listening device to check for leaking water across the seat, and then the operating valve is located at the base of the hydrant. Flush hydrants, a lot of people miss this. One of the wrong answers on the test is flush hydrants are for flushing. What flush means is they're flush against a wall or the ground, and they use those where post hydrants are not suitable. When you flush the system, periodically you want to flush your dead end systems. A good time of the year is when the flows start to back off, like in the fall or in the spring. When they're low, you can do them during periods of time when there's low flows, and what that does, it keeps the water moving in the system. Dead end systems can cause water quality issues, so that's another time. Also, when you have a water quality issue, it's another time to flush the main. When you get customer complaints, that's another time you want to flush. You need to be careful of environmental concerns. This thing attached to this hydrant is a mechanism or an apparatus they use to dechlorinate the lines. You can see the little white cap on top of it, and that's where they put the tablets in, so as the water passes through it, it dechlorinates the water, so that any water going downstream into a river, that won't cause fish kill. So also you want to, during periods of low demand is when you want to flush your hydrants. You want to notify the customers in their billing. Let them know when you're going to be flushing the line, so you don't get a large amount of calls into your main office complaining that the water's dirty or it's got the appearance that there's rust in it and that. So that can get into your customers' homes, and if they know that you're flushing and the reason that you're flushing, you want to explain why you're flushing, then that will minimize the calls. Also, you want to notify your hospitals, dialysis patients, and that need clean water, that you're going to be doing that, and let them know that they can let their tap run until it clears up. and anybody that may be affected. When you flush the system, you want to flush it when the system's been contaminated, or whenever you've installed new or repaired main lines. When you flush the hydrant, that helps remove the taste and odor causing deposits. It helps remove incrustations that may restrict flow, and it helps remove rust and that cause water quality problems. With the flushing procedure, you want to avoid traffic areas, especially you don't want to flush in the wintertime in freezing conditions because you may cause accidents. You want to open the hydrant fully for 5 to 10 minutes to stir up the deposits. Don't let any nearby areas drop below 20 psi. You have to maintain at least 20 psi at all times in your system. And then you want to record pertinent data like odor, the water appearance, the times and places that you were doing the flushing. Firefighters, if you have several firefighters hooked to a main line through your hydrants, you can create a negative pressure. Dead-end systems will likely have an inadequate flow for firemen, so you need to be mindful of that. And then firefighters should know that it is a dead-end system and they may experience problems, so you probably ought to communicate with your firefighters and let them know. All systems should be exercised annually. All the valves in your system should be exercised annually. You should have a program to go exercise those mainline valves. And the valves are used to isolate sections of the system. Generally, you'll have a gate valve down there on the main line, and it's mainly used to isolate, and they should be open all the way on a gate valve. Gate valves are the most commonly used valve in a distribution system. They're for isolation purposes only. They need to be all the way open or all closed. And what you can do is cause cavitation, like in this picture here, across the gate seat. And what you'll get is cavitation, and that will form, and these collapsing bubbles will cause cavitation. Fully open, a gate valve has the least amount of head loss of valves because it's a clear path. And you can repack those without taking it out of service. So right now we're going to pause and start part 2 of the operation and maintenance video.